Hello, dear aspirants. This is Dr. Saurabh's classes. So, this is our contact number, which is 98367 93076. Again, I am repeating that 98367 93076. Please feel free to contact on this number. So, if you have any doubt for mathematical doubt or etc., or any other subject doubts, you can call on this number. So, we can help you by various manner, and the email id is also given here, which is saurabhsclasses@gmail.com. If you can mail also. Okay, so the we are now solving the TIFR GS 2025 questions. So this question is appeared on this examination, and the question is telling us that let our n greater than 1 be a positive integer, and let A be a matrix which is Aij, and I and J is lying between 1 and n, be an n cross n matrix such that the entry Ai comma I plus 1 is equals to Ci. Okay, for I is equals to 1 to dot 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 n minus 1, and an1 is equals to cn, where c1 c2 dot 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 cn are real numbers and all the other entries are 0. Which of the following sentences is the correct regardless of n? Our option A is telling us that determinant of id minus a to the power n is equals to 0 if the product of where our I is running from 1 to n, ci is equals to 1. And our option B is telling us that determinant of id minus, that means the identity matrix, minus a to the power n greater than 0 if our product, which is where our I is running from 1 to n, ci greater than 0. And option C is telling us that the C determinant of I minus a to the power n less than 0 for this product greater than 1. And option D is telling us that determinant of I minus a to the power n greater than 0 if the product is greater than 1. So what can be done in this question? So we have to know about the structure of A. So the matrix A is a cyclic matrix that shifts each row of the identity matrix and multiplies the elements by the constants, which is my C1 C2 dot 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 Cn. Okay, so A is a sparse matrix. Now what is a sparse matrix? That will be explained later, with Ci on the super diagonal for I equals to 1 2 dot 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 n minus 1, and our Cn is the bottom left corner or the wrap around term. Okay, so A represents a circulant matrix that cyclically shifts the indices and the scales by C1 C2 dot 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 Cn. So now we are going to think about the eigenvalues of K. So now the eigenvalues of A are determined by the characteristic polynomial, and they depend on the product, which is this product of I equals to 1 to n ci. And what will happen? Okay, so our a to the power n wraps around n times to cycle back to the original position. Okay, so the eigenvalues of A can be expressed in terms of the nth roots of unity by unity scaled by this c1 c2 dot 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 cn. So now the step 3 will be my determinant of ai minus a to the power n. Let me change the color. Okay, determinant of I minus a to the power n. So this is influenced by whether the eigenvalues of an equals to 1. The eigenvalues of n equals to 1, and specifically our a to the power n has an eigenvalue 1 if our this thing is equals to 1. Okay, so this follows because the eigenvalues of a to the power n depend on this product, and the product of the Ci. Okay. So now we are going to analyze each options. Okay. So option 1 is telling us the determinant of I minus a to the power n is equals to 0 if the product is 1. Okay. So if our product be 1, then our a to the power n has an eigenvalue equal to 1, then which implies that our I minus a to the power n, n's determinant is equals to 0 because 1 minus 1 is equals to 0. So first statement is true. Okay, so the correct option of this question will be my option A. So now we have to think about our B, C, D also. As it's a single correct question, we can easily leave the question now. But again, we have to think about B, C, and D, why they are false. And our option B is telling us that determinant of I minus a to the power n greater than 0 if the product I equals to 1 to n Ci greater than 0. So this is not necessarily true because the determinant depends on the exact values of Ci. For example, if the product greater than 0 but the eigenvalues of a to the power n values larger than 1, then determinant can be negative. So our this statement will be false. Okay. So our option B can be false. So now we have to think about our option C, which is telling us that determinant of I minus a to the power n is less than 0 and the product if our product is greater than 1. Okay. So if our product is greater than 1, it does not guarantee that the determinant is negative. The determinant can depend on how the eigenvalues are distributed. So this statement is not necessarily true. So our option C will also be ruled out. So let's check the option D, which will tell us that identity minus a to the power n, the determinant will be greater than 0 if the product is greater than 1. Okay. So as argued in C, even if the product is greater than 1, it does not guarantee that the determinant is positive. So the determinant depends on how the eigenvalues interact. So again the statement D will be false. So the correct option of the state of this question will be option A. And I am telling that please feel free to call on this number, which is our contact number, and our team will help you for solving the mathematical doubts. Okay, thank you guys, hope you understood. Thank you.